Namaskar, I am Dr. Aarti Chaudhary, Assistant Professor in the Department of Ancient Indian History, Culture and Archaeology at Vasant Kanya Mahavidyalaya, Banaras Hindu University. I welcome you once again in this 12-week course titled History of Science and Technology in Ancient India from Harappan Civilization to 7th Century CE. Today, we are going to discuss Module 9 and Lecture 4. The title of Module 9 is Mathematics and Astronomy in Ancient India, and the title of Lecture 4 is Mathematics and Astronomy in Buddhist Literature. Till now, we have discussed mathematics of Aryabhat, astronomy of Varamihir, and the text of Brahmagupta. And now we are moving towards the Buddhist mathematics and astronomy. So the first learning objective of this topic is to understand the philosophical and cosmological worldview of Buddhism. The second learning objective is to explore the role of logic and numerical thought in Buddhist philosophy. And the third learning objective is to know the historical contributions of Buddhist scholar to Indian scientific thought. In this particular lecture, we are going to discuss following topic like numerical structure mentioned in Buddhist text, cosmological mathematics and geometry, as well as early mathematical logic and reasoning were described in Buddhist text. Buddhist mathematics and astronomy are significant in the intellectual history of ancient and medieval Asia. Rooted in the broader context of Indian scientific tradition, Buddhist scholars contributed significantly to mathematical reasoning and astronomical observation, especially as Buddhism spread beyond India to regions such as Tibet, China, Korea and Japan. Their work was driven both by practical need such as calendar making, ritual timing and monastic regulation, and by a philosophical inclination toward logic and systematic thinking. Buddhist texts often reflect a blend of metaphysical insight with rigorous numerical analysis, including early explorations in logic, set theory like ideas and large number computations. In astronomy, Buddhist scholars adapted and transmitted Indian astronomical models while also engaging the Chinese and later Islamic system, resulting in a unique fusion of observational and theoretical approaches. Now, scholars in Buddhist mathematics and astronomy. First name which is very significant, and that is Nagarjuna, 2nd century CE, a pivotal figure in Buddhist philosophy whose ideas on sunyata, emptiness, influenced not only metaphysics but also conception of the infinity, a key aspect in mathematical observation and abstraction. Second name is Dignaga, 5th century CE, regarded as the founder of Buddhist logic. Hetu Vidya developed formal structures of inference that resemble early mathematical logic and reasoning. His work laid the groundwork for later developments in epistemology and analytical philosophy. Second name, which is very important in terms to understand the Buddhist mathematics and astronomy by the different scholars, that is Dharmakriti, 7th century CE, a successor to Dignaga, further advanced theory of perception and inference. refining the principle of valid knowledge, praman, and contributing to proto-mathematical thought. Next name is Vasubandh, the time period in between 4th-5th century CE, whose Abhidharmakosh systematically categorized mental and physical phenomena using numerical and logical structure, aiding early developments in mathematical classification in the Theravada tradition. Next name is Buddha Ghosh, and the time period 5th century CE, integrated numerical reasoning in his Vishuddhimagga, particularly in his description of cosmology and meditative state. These thinkers collectively demonstrate that Buddhist scholars engaged deeply with mathematical and logical system, not just in abstract theory but as practical tool to explore consciousness, logic and the universe. So, on the basis of the description of these whole scholars, what they wrote in their text, we found a clear information regarding the mathematical and cosmological understanding and approach of Buddhist literature towards the society, which is very important in terms to understand the relationship between the mind, body and the cosmos for the successful and healthy living. In the Pali canon, especially within the Vinay Pitak and Abhidhamma Pitak, mathematical ideas emerge through systematic enumeration and classification. The Dhamma Sangini, a key text of Abhidhamma, organize mental and physical phenomena into structured numerical lists to aid in analysis and memorization. Numbers serve not only to enumerate but to represent the interdependent nature of mental factors, statistics, helping practitioners understand the intricate dynamics of consciousness. The Anguttar Nikaya, another Pali text, is itself structured numerically, organizing sutta according to the number of topics they cover, from single to set of 11. Cosmological texts in Buddhist literature such as the Vishuddhimagga by Buddha Ghosh and the Mahavastu offer geometrically and numerically a structured description of the universe, including Mount Meru, the continents, ocean and heaven. These descriptions, while symbolic, reveal an implicit mathematical awareness in representing spatial and temporal infinity. The concept of kalpa, aeon, for instance, is used in various texts like the Anguttar Nikaya and Saddharma Pundarik Sutta, Lotus Sutra, to express unfathomably long period, often explained using analogies involving grains of sand or drops of water to highlight impermanence and the vastness of world. Buddhist literature makes frequent use of extremely large numbers to convey the vastness of time, space and spiritual progression. Sutras such as the Avatamsak Sutra and Lalit Vistar Sutra list numerical values that go far beyond common usage, using terms like Nayut, Koti, Padma and Mahapadma. These numbers are not used for calculation but to emphasize the immeasurable qualities of Buddha and the incomprehensive length of cosmic time kalpa. They serve to humble the conceptual mind and highlight the scale of the Buddhist cosmos and spiritual endeavor. So, on the basis of these information, we can understand the understanding of cosmological calculation with the number system. Of course, this number system is just related to the planets, their movement, their speed, and another thing is the celestial movement in the universe. These all things are basically responsible for the smoothing activation of any living thing in this universe on this earth. Now, the numerical structuring in doctrine. Many early Buddhist texts, particularly the Pali Canon, organized teaching into numbered lists. This methodological structuring is especially prominent in the Abhidhamma Pitaka, such as Dhamma Sangini, where mental phenomena are enumerated for analytical study. Similarly, the Anguttara Nikaya arranged Sutta by number from set of 1 to 11 topics. The Vinaya Pitaka also follows this structure to list rules for monastic discipline. This enumeration add memorization, support structured reflection and foster doctrinal clarity. It reflects a systematic approach to mental training and ethical development. And this ethical development, mental training and the doctrine is basically based on the numerical system what we found in Abhidhamma Pitaka. And this number system and these calculation is just related to the cosmic activity which gives strength to the human being for their activity in this movement world. Cosmological mathematics and geometry. Buddhist cosmology incorporates geometry and mathematical framework in its description of the universe. Texts like the Visuddhimagga and Mahavastu detail the structure of the cosmos, placing Mount Meru at the center, surrounded by 4 great countries and concentric rings of ocean and mountain ranges. Above and below lie various rims forming the 31 planes of existence. Through symbolic, these descriptions reflect a sophisticated vision of cosmic order and proportionally. Geometry here serves to visualize spiritual cosmology, reinforcing the vastness and complexity of the world. Now, the philosophical and symbolic use of number. Philosophy is very important because the philosophy decides the ideology of a particular theory. Philosophical and symbolic use of number. Number in Buddhist literature often serve a symbolic function. The Buddha frequently used numerical analogies like comparing a kalp to the time it takes to wear down a mountain by brushing it once every 100 years. To illustrate the enormity of time and the rarity of encountering the dharma. Terms like asankhya, incalculable, express the immeasurable nature of karmic consciousness, compassion and wisdom. These metaphors help explain to core teaching of impermanence, anicca, non-self, anant and dependent origination, pati kam saput ada, showing the limits of conceptual understanding in grasping ultimate reality. Early mathematical logic and reasoning. The Buddhist literature and the Buddhist philosophy developed precise methods of reasoning akin to early mathematical logic. Thinkers such as Dignaga and Dharmakriti laid the foundation of Buddhist epistemology, Praman theory, using a structured argument form similar to syllogism. Their work involved binary distinction, for instance valid-invalid inference, causal logic and inferential reasoning, contributing to the development of Indian logic. While not mathematical in a modern sense, this logical rigor reflects a deep concern with clarity, consistency and truth, essential qualities in both spiritual and intellectual inquiry. Logical structure of inference in Buddhist philosophy. The logical structure of inference in Buddhist philosophy as developed by Dignaga in the 5th century CE and refined by Dharmakriti in the 7th century CE represent one of the earliest formal system of logical reasoning in India. Known as the Buddhist syllogism, this system is composed of 5 distinct components designed to establish valid knowledge praman through structured inference anuman. The first step is to proposition pratigya, which is the thesis of claim to be proven, such as there is fire on the hill. This is followed by the reason hetu, which support the claim, for example, because there is smoke. The third component is the example drishtant, which demonstrate a general rule connecting the reason to the conclusion, as in wherever there is smoke there is fire, such as in a kitchen. Next is the application upanya, which applies the general example of the specific case at hand. There is a smoke on that hill. Finally, the conclusion nigaman follows, affirming the claim based on the reasoning, therefore there is fire on the hill. So, the logical study in Buddhist literature is very significant, and the base of this logical study is the philosophy, what we already discussed in our previous slide. So, this 5-step format is more elaborate than the 3-part syllogism found in Aristotelian logic and emphasizes both the generality of the reasoning and its specific application, making it contextually grounded and pedagogically rich. It was widely used in Buddhist scholasticism, especially in monastic debate and philosophical analysis, and it significantly influenced Indian logic Hetu Vidya as a discipline. The clarity and precision of this inference model also laid a foundation for rational discourse and epistemological inquiry in Buddhist intellectual tradition. Comparison with the other Indian tradition, Buddhist mathematical ideas often resemble those found in Jain and Hindu tradition, especially in naming and ordering large number. However, their application differs notably. Jainism employs numbers to classify entities and time cycles systematically, while Hindu cosmology includes vast time span like yuga. Buddhism, in contrast, uses numbers more philosophically to symbolize non-permanence, immensurability and spiritual qualities rather than create fixed ontologies. Thus, Buddhist mathematics emphasizes the conceptual transcendence of numbers rather than their descriptive accuracy. Buddhist texts, especially those developed during the classical and medieval period, reflects a thoughtful engagement with mathematical ideas such as the number system, fractions, mensuration and geometry, often linked to philosophical and practical needs. The number system in Buddhist literature generally follows the Indian decimal system. So, it is very important that the number system in Buddhist literature generally follows the Indian decimal system, and Buddhist scholars like their Jain and Hindu counterparts showed interest in very large numbers, sometimes for cosmological descriptions. Canonical texts such as the Abhidhamma mention numerical classification and progression, sometimes extending into the millions and beyond, reflecting the systematic understanding of magnitudes. In terms of fraction, Buddhist mathematicians demonstrated proficiency in dealing with part-whole relationship, particularly in contexts such as the division of donations, distribution of offering and calculation in monastic rules. The use of fraction was often practical, and their treatment is seen in both Indian Buddhist texts and in adoptions made by Chinese and Tibetan Buddhist scholars who also incorporated local mathematical techniques. We can see here the Buddhist monastery, their discipline, their rules regulation, their understanding on the cosmological activity, these all sense is basically based on a pure scientific theory, and their calculation pattern, their understanding to this scientific aspect is very significant to understand the mathematical knowledge and astronomical knowledge of Buddhist monks, Buddhist the scholars at that contemporary time period. Mensuration or measurement of space and volume was important in the construction of stupa, monastery, mandal and ritual space. As we already discussed, in Buddhism they built the stupa, they built the monastery, they just perform their prayer, and these all things are not just practiced by the monks on the basis of their daily routine. These all things are just related to the cosmic activity as well. On the basis of the astronomical calculation, they build their this kind of monasteries, this kind of stupa, as well as they pray, they perform their praying parameters on the basis of this calculation. So, their mathematical and astronomical knowledge is significant. Buddhist architectural texts often include rules for calculating area and volume, particularly of circular and rectangular structure. These principles were applied in real world temple construction as well as in the symbolic design of cosmological diagrams. In geometry, Buddhist texts and commentaries contain discussion on shape like circle, square, triangle and rectangle, used not only for practical construction but also for metaphysical visualization in mandal and cosmological chart. While less focused on theoretical proof than later Hindu treatises, Buddhist works often contain clear procedural knowledge such as determining perimeters, areas and alignments. In Tibet and East Asia, Buddhist scholars adapted Indian geometry into their local context, integrating it with Chinese surveying and calendrical system. So, on the basis of this whole information, the cosmic understanding by the Buddhist literature, the cosmic understanding by the Vedic literature, and at that time of period the Buddhism and the Vedic culture is parallelly grow in the Indian context. So, it is very obvious they influence to each other science in the field of science and technology. So, on the basis of this in a whole detail, we can say Buddhist mathematics and astronomy reflect a rich synthesis of spiritual insight and scientific inquiry. While primarily rooted in practical needs, calendar regulation, ritual timing and monastic life, their contribution reveal a deep respect for logical reasoning, numerical precision and cosmological understanding. Buddhist scholars not only preserved and adapted Indian mathematical and astronomical knowledge, but also played a vital role in transmitting it across Asia, influencing scientific tradition in China, Tibet, Japan and beyond. Their legacy lies in a unique integration of contemplative philosophy with empirical observation, making Buddhist scientific thought an essential part of the broader history of science and mathematics. So, if you want to enhance your knowledge regarding this topic, you can prefer these references, as well as you can also prefer the book History of Science and Technology by S. N. Sen. So, thank you for your patient listening. Namaskar.